Okay, let's rattle through some of these resolving forces questions then. So this is the first one. So here's our diagram. I'm going to take positive x to be in that direction, positive y to be in that direction. It's telling me the forces are in equilibrium. So I know that the sum of the x components must equal 0, and the sum of the y components must also equal 0. So first of all, working in the x direction, the 60 is completely there. The r has no horizontal component. This one is going to be minus s, and if that is 60, that there is 30. So you could either use the angle 60 to the vertical, but I like to keep it with this angle, so I'm going to say that that is s. The x component is adjacent, so it's cos 30. So 60 minus s cos 30, and on this force, no horizontal component, equals 0. Then I'm going to work with my y components. Nothing there. R is entirely in the y direction, plus s sine 30 minus 80 equals 0 is my second equation. So that's all the mechanics over with. Now I'm just going to deal with the algebra. From equation 1, 60 equals s cos 30. So s is 60 divided by cos 30. So on your calculators, you can put that in exactly as you see it, if that's the way that you like to operate. Press equals, and I am in radians there, so I don't want to be in radians. So change that to 3 and try again. 60 over cos 30 close brackets equals 40 root 3, which is 69.3 newtons. From equation 2, I want r. I now know what s is. So r equals 80 minus 40 root 3 sine 30, replacing the s with the 40 root 3. If you haven't got it as 40 root 3 in your calculator, then you want to store that in your memory so that you aren't introducing a rounding error. Now, to use the memory button on this, what you would do is shift RCL, so you're doing store, and then save that in A. So if you press that button now, that should come up, answer is stored in A. So that is safe as a complete number. So now I can type that into my calculator as 80 take away alpha A sine 30 close bracket equals 80 minus 20 root 3, which is 45.4 degrees. Newtons, sorry, not degrees. Okay, so if you are rounding something off, make sure you keep the original in your calculator. So that's question 1. Question 2. So we've got a particle moving on a smooth horizontal floor under the resultant action of 3 horizontal forces of those magnitudes shown in the diagram. Show that the resultant of the 3 forces has a magnitude of 20, and find the angle it makes. So this time it's not equal to 0. Again, I'm going to take plus x to be that direction, plus y to be in that direction. The x resultant will be the sum of the x components. So going around again, if that's 30 to the horizontal is 60, so it's going to be 12 root 3, nothing there, minus 4 root 3 cos 60. So in your calculator you can type that in as you see it. 12 root 3 take away 4 root 3 cos 60, 10 root 3. Ry will be the sum of the y components of the forces, which will be 16 less 4 root 3 sine 60, which again you can just type in your calculator. 16 less 4 root 3 sine 60, which is 10. So we want the resultant of the three forces as a magnitude of 20. So now R is the square root of 10 squared plus 10 root 3 squared. So 10 root 3 squared is 300 plus 100 is 400, which is 20 newtons as required. So that was a show that. And find the angle it makes with the force of magnitude 16 newtons. So what we've got is we've got Rx going in that direction, 10 root 3. We've got Ry in that direction, 10. We've got the resultant going up here, which is of magnitude 20. And what we want is that angle there. So that angle is going to be, that's 10, that's 20. So that's the adjacent, that's the hypotenuse. So cos of theta will be 10 over 20. Theta will be cos to the minus 1 over half. In case you don't know what that is, again you can use your calculator. Shift cos 0.5 equals 60 degrees. So it's 60 degrees to the vertical. So that's question 2. Question 3 now. Diagram shows a body of mass 6 kilograms suspended in equilibrium by two light inextensible strings AC and BC attached to two fixed points A and B on the same horizontal plane. The strings AC and BC are inclined at 45 and 60. Find the tension in the string AC and the tension in the string BC. So we're going to have a 6G force acting downwards, which is going to produce two different tensions, T1 and T2. If we work with Z angles there, that one will be 45 and that one will be 60. And I'm going to take, as usual, plus X and plus Y in those directions. So it's in equilibrium. So in equilib, therefore sum Fx equals 0, sum Fy equals 0. So summing in the X direction first of all, I'm going to have plus T2 cos 60 minus T1 cos 45 equals 0, and those are just the two forces that have got horizontal components. And then in the y direction, I'm going to have T2 sine 60 plus, this time because both of those are pulling upwards, T1 sine 45 minus 6g equals 0. So you've done the work as far as the mechanics is concerned, so you know that you've got the marks for those. Now you've got to deal with the algebra. So with this particular question, you're going to have to, from equation 1, rearrange to get T1 equals, and then substitute into equation 2. Because sine and cos of 45 are the same, you could add them, but it's less likely you would have spotted that in an exam, so I'll stick with the rearranging method. So from equation 1, T1 cos 45 equals T2 cos 60, because that's negative, making it positive. So T1 is T2 cos 60 over cos 45. Cos 60 over cos 45, you could work that out straight away if you wanted to. Let's go with the fraction button. Cos 60 over cos 45 equals, so that is root 2 over 2, so T1 is root 2 over 2 T2. Put that into equation 2, call that 3, so we'll come back to it. So in 2, I want T2 sine 60 plus T1 sine 45, which is root 2 over 2 T2 sine 45. So the T1 I replaced with the root 2 over 2 T2 sine 45, and if I take the 6g over, I get that. Now here I can take the T2 out as a common factor, I can evaluate what that is. So it's root 2 over 2, so if I multiply that by sine 45, that's that part of it. And now I'm going to add sine 60 to give me that. So T2 is going to be 6g divided by that. So what I'm going to do is, I don't need to store that in memory because it's in my answer memory. So I could just do 6 times 9.8 divided by answer 43.0 T2 comes out to be, and then to get T1 I multiply that by root 2 and divide by 2. So times root 2 equals that, divide by 2 equals 30.4 newtons. So that's question 3. Okay, so then we come to question 4 and 5. So there's question 4. Let's take a look at it. Diagram shows the particle in equilibrium under those forces. Find the values of R and S. So you can see how repetitive these questions are. So sum of Fx equals 0 will be 8 minus R cos 45 minus S, don't like S's, they're confused with my 5s, S cos 30 equals 0. Sum of the y components must equal 0. There is no y component of that. It's going to be R sine 45 minus, because this is pulling in the negative y direction, S sine 30 equals 0. So that's the mechanics over with. Now I have to pick my way through that. I will go with this one because it's got fewer terms in it. So R sine 45 equals S sine 30. S is R sine 45 over sine 30. So S again, why not? Because we can. Sine 45 over sine 30 root 2. So R root 2. So I've used equation 2 to get R and S in terms of R. I'm now going to put that into equation 1. So in equation 1, and I'm going to make those, I'm trying to find, I'll make those positive. So I'm going to have R cos 45 plus S, which is R root 2 cos 30 equals 8. Take the R out as a common factor. Equals 8. So to get the R on its own, I need to divide by all of that. Which I can just do on my snazzy clever calculator. Fraction button, 8 on top, and underneath open bracket, cos 45 close bracket plus root 2 cos 30 close bracket equals, ooh, what happened then? Maybe it's not as snazzy as I thought. Try it again. Fraction button, 8 on top, cos 45 close bracket plus root 2 cos 30, oh, it's a double close bracket, equals 4 root 6 minus 4 root 2, which is 4.1. Let me just check my answers. R is 4.1, so that's correct. And then in 3, S is going to be 4.1 times root 2. My calculator's got the full string on, so I can just times root 2 equals 5.9 newtons. So that's question 4. Question 5. 3 horizontal forces, 18, 15 and 9 act at a point. So this is a resultant one again. So the x components of the resultant is the sum of the horizontal components plus x plus y. 15 cos 30, nothing there, minus 9 cos 30. So you can work out what that is. 15 cos 30 minus 9 cos 30 equals 3 root 3 newtons. Sum of the y components will give you the y resultant. So that's going to be 18 minus 15 sine 30 minus 9 sine 30. Sine 30 is a half, but we can just type it in. 18 minus 15 sine 30 minus 9 sine 30 equals 6. So the magnitude of the resultant is the Pythag. So 3 root 3 squared (27) plus 36 root 63. Okay, and the magnitude of that, so that's the magnitude, then the direction will be, so we have 3 root 3 that way, 6 that way, theta, tan theta will be opposite over adjacent, so theta will be tan to the minus 1 of 6 over 3 root 3 close bracket equals 49.1 degrees. So it's 49.1 degrees above the horizontal. Okay, so that's question 5. Motoring on to 6 and 7. Question 6. Diagram shows a body P of mass 30 kilograms. So I'll just get my different color pen. So we're going to have a 30 G force acting downwards. It's in equilibrium. If that's 45, that's 45. That's 30. Tension in the string OP. Well, that's the weight. So that's going to be 30 G. And then these two tensions, T1 and T2. So A tension in OP equals 30 G, which is 30 times 9.8, 294 newtons. for part B. Right, this is where, so draw a diagram showing the forces acting on the point O. That's what I've done there. So that's what they're looking for. So you've got your three forces, 45 degrees, 30 degrees. And then for C, now we resolve, again, make clear what sense of direction you're taking. So positive y, positive x in that direction. So sum of x forces equals 0. That would be T2 cos 30 minus T1 cos 45 equals 0. Y components equals 0. T2 sine 30 plus T1 sine 45 minus 294 equals 0. So from 1, T2 would be T1 cos 45 over cos 30. Take that over, divide by cos 30. That equals cos 45 over cos 30 equals root 6 over 3. We need to put that now in 2. So T2, instead of T2, I'm going to have that sine 30 plus T1 sine 45 equals 294. I can take the T1 out of that as a common factor, and I can simplify what we've got there. So root 6 over 3 times sine 30 was root 6 over 6 plus sine 45, which is root 2 over 2, equals 294. So plus sine 45 equals, so that's what that all comes down to. So I'm now going to do 294 divided by that. So 294 divided by previous answer is 263.6. Yep, 263.6 newtons. And then for T2, so in 3, T2 will be that answer times root 6 divided by root 3. So I'm not cancelling that. Times root 6 equals divided by 3 equals 215.2 newtons. So that's question 6. Question 7. I'll try and get in down there. I have to trim this a bit further. So see how we do with this one. Diagram shows 4 horizontal forces acting at a point, given the force in equilibrium, blah 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 blah. Plus x plus y, sum of x equals 0, 40 minus t cos theta minus, right, let's think about this here. That's 180. There's 80, 120. So that angle there is 60. So minus 50 cos 60 plus, this is pulling in the positive x direction, 60 cos 80 equals 0. So let's just check we've covered everything there. There's 1, 2, 3, 4 forces. 1, 2, 3, 4. Don't worry about simplifying it yet. Let's do all the mechanics first. Sum of the y equals 0. That isn't going to appear. I'm going to have t sine theta minus 50 sine 60 minus 60 sine 80 equals 0. Right, now this time we don't know t or theta. So the method that we use here is to rearrange that to give t cos theta equals, rearrange that to give t sine theta equals, and then I'll talk about what we can do from there. So from 1, t cos theta will equal, so I'm just taking that the other side to make it positive, 40 minus 50 cos 60 plus 60 cos 80. Call that equation 3. From 2, t sine theta will be 50 sine 60 plus 60 sine 80. Now, in order to deal with this, to find theta, we're going to divide 4 by 3. And what will happen then is the t's will cancel, and you have sine over cos, which is tan. So you do 4 divided by 3, and you get t sine theta over t cos theta equals that all over that on top. T's will cancel, sine over cos equals tan. Now you should be able to, once again, put all of that in your calculator in one go, but it's a pretty big string. I don't know, let's see. So on top I've got 50 sine 60 plus 60 sine 80. And then on the bottom, I want to contain this all in brackets, so then showing, making sure the calculator works it out first. 40 take away 50 cos 60 plus 60 cos 80, and then I'm going to double bracket close and fingers crossed 4.02. I got an answer for this one? Yes. Okay, so 4.02. So theta will be the inverse of that, and again don't cancel that, use it. So shift tan ans close bracket 76.1 degrees, which is correct. Whew. So I know what the angle is. So now that I know that, I want to hang on to it, so I'm going to store that, shift recall A. So that is now stored in memory A, and I want to put that into equation 4 probably. So T is going to equal that divided by sine theta. So T will be 50 sine 60 plus 60 sine 80, all divided by sine theta, which is 76.1, or A in our memory. So on my calculator, I am going to do cancel, fraction button, on top 50 sine 60 plus 60 sine 80, close bracket, and on the bottom sine alpha A, close bracket, because that's where I'd stored 76.1. That equals 105.5, which is correct. So there is a good example of using your memory button on your calculator, the fraction button, to type it in exactly as you see it. So that's question 7. 3 more to go. Question 8. Four coplanar forces act at a point, magnitude and direction of resultant. So Rx equals the sum of the x components. Keep these the same. So it's going to be 3 plus 16 cos 60. No component, minus 10 cos 60 equal, oh, it doesn't equal 0, it's a resolved force. So we can work out what that is. 3 plus 16 cos 60, close bracket, less 10 cos 60, close bracket, equals 6. Ry, sum of the y components, no component of 3, 16 sine 60 plus 11 root 3 plus 10 sine 60. Yeah. Okay, so 16 sine 60 plus 11 root 3 plus 10 sine 60 equals 24 root 3. So we've done the resolving, deduce the magnitude and direction of the resultant. So the resultant is 6 squared plus 24 root 3 squared. So answer squared plus 36 equals the root of 1764, which is 42. Direction, Rx is 6, Ry is 24 root 3, so tan of theta is opposite over adjacent. Theta equals shift tan, oh god, shift tan fraction button 24 root 3 over 6, close the bracket, equals 81.8 degrees above horizontal. $10 marks for that? My god. That was a very straightforward one. Question 9. Resultant again, so sum of, Rx equals the sum of the x components plus x plus y, 56, minus, now this time they've been sneakier. This time, if that's alpha, then the horizontal component is going to be opposite, which is sine. So 60 sine alpha. And if tan alpha is 3/4, tan is opposite over adjacent. That means the hypotenuse is 5. So sine of alpha will be opposite over hypotenuse, which is 3/5. So what you've got there is 56 minus 60 times 3/5. So 0.6 times 60 equals 36. 56 minus 36 is 20. So that's 20 newtons. Then Ry will be the sum of the y components, which will be 78 plus 60, and this time it'll be cos alpha minus 27. Cos of alpha is a over h, which is 4/5, minus 27. So 0.8 times 60 is 4/5. So I got 78 minus 48 minus 27 equals 3. So the resultant will be the square root of 20 squared plus 3 squared, which is the square root of 409. She's not going to give me the right answer. Okay, let me just check this again. 56 minus 60 sine alpha. Tan alpha is 3/4, opposite adjacent. So in a right angle triangle, that's going to be 5. So sine is going to be 3/5. 56 minus 0.6 of 60 is 36. So 56 minus 636 is 20. Ry is going to be 78 plus, that's why, that's a plus. So 0.8 times 60 is 48 plus 78 minus 27 is 99. So that should be 20 squared plus 99 squared. 20 squared plus 99 squared. Square root and 101, yeah. So the resultant is 101 newtons, and its direction Rx is 20, Ry is 99, shift tan of 99 over 20 equals 78.6 degrees. So the slightly different thing there is the fact that they don't want you to calculate the angle in degrees. They want you to use this fraction relationship to work out the corresponding fractions for sine and cos. And finally, question 10, see if I can fit it down here. So 3 horizontal forces, 8, 12 and 9 act in those directions. Find the magnitude and the result of these forces and the angle between them. So plus x plus y, resultant, so Rx equals the sum of Fx, which will be, so if that is 120, that's 90, which means that is 30. So you've got 9 minus 8 cos 30. So 9 minus 4 root 3. Ry is going to be 12 minus 8 sine 30. Which is 8. So the magnitude R will be the square root of 9 minus 4 root 3 squared plus 8 squared, which equals 9 minus 4 root 3 squared plus 8 squared, which is 64. Square root your answer, 8.3 newtons. And then the direction theta, that's 8, that's 9 minus 4 root 3. Tan theta will be opposite over 9 minus 4 root 3. So theta equals shift tan frac 8 on top, 9 minus 4 root 3 close bracket equals 75.5 degrees above the horizontal. And that's it. That's them all done.